two integrals. First integral 0 up to 1 dt over square root of 1 minus t to the power 4 over the other square. First of all, the difficulty about this problem is that I don't think either of the integrals has elementary antiderivative. But I do think we can work out their ratio, right? The other definite integral is 0 to 1. The only difference is that we have a plus. So I'm thinking maybe we can use trigonometric substitution to begin with. First, I'm going to denote the first integral as I1 and the bottom integral as I2. Right? Then I'm going to say for the integral I1, can I let, for example, t squared equal to perhaps sine x. Right? Then all of a sudden, of course, I have to change the boundaries. Right? So t goes from 0 to 1. Right? So that means sine x should be in between 0 to 1 as well. So that tells me maybe I can just restrict x in between 0 to half pi. Right? I think that will be enough. And that is my new boundary. Right? Just keep this in mind. Then I'm going to say, okay, then that means t is equal to sine x to the power of half. Then I can just easily work out dt. dt is half of sine x to the power of negative half. Right? Then I'm going to use chain rule times derivative of the inside. That is cosine dx, of course. Right? So to simplify everything, I can have cosine x dx, and I have 2 at the bottom, and I have negative sign should be at the bottom, right? That's square root of sine x. Okay, so now I'm going to say the inside function, the integrand. I'm looking at the bottom. So the square root of 1 minus t to the power of 4 is equal to square root of 1 minus sine square. Right? That is, of course, cosine x, right? Absolute value. Right? I don't need absolute value because within this restriction. Right? So that tells me the integrand inside, right? F of t this time is equal to, first of all, I have dt. Then I have cosine x at the bottom. Right? So dt cosine x at the bottom. Right? Sine x. And the square root of sine x. Cosine gone. So that means my first integral should be equal to, and just take out the constant half. Right? That is equal to half of the integral. Change the boundaries, right? The old boundary is 0 to 1. The new boundary, like I said, it's 0 to half pi, right? 0 to half pi. And dx over square root of sine x. Right? Still, there's no antiderivative, right? No elementary antiderivative, but this is all I need. Because then I'm going to look at my second integral, I2. Right, for I2, so what I'm going to do with it. So once I see the plus, that tells me maybe I should let t squared equals tangent maybe alpha. right, tangent alpha. Because that way I can say that the bottom, the 1 plus t to the power of 4 can now equal to the square root of 1 plus tangent square alpha. Right? That is simply square root of 1 over cosine square alpha. Right? That is equal. I think it's positive. Right? 1 over cosine alpha. Right? Positive because the old boundary, like I said, the old boundary is between 0 and 1. Right? So that tells me tangent alpha is also between 1, 0, and 1. Right? That tells me alpha must in between 0 and pi over 4. All right, all good. So that means cosine of, I don't need absolute value, right? So this is what I need. So so that tells me t is equal to tangent alpha to the power of half. So dt should be equal to half times tangent alpha to the power of minus half using the chain rule. What's the derivative of the inside tangent? I believe is 1 over cosine square alpha, right? Positive. So that means dt is actually equal to two at the bottom. Tangent square root of tangent at the bottom. Right? Then times 1 over cosine alpha. 1 d alpha. D alpha. 1 times d alpha. And this time cosine square at the bottom. Right? So that means that is equal to d alpha over twice of, like, tangent is equal to sine over cosine. Sine, hang on. So I'm done with dt. So right now let's look at the integrand, the inside integrand. The integrand should be equal to, right? Maybe it's called g of t. The integrand g of t, dt over the square root of 1 plus t to the power of 4. So 1 square root of, so that's the bottom equals, like I said, 1 over cosine alpha. Right, so 1 over cosine alpha. So first of all, dt is this. Right? Twice of square root of tangent alpha cosine square alpha, right? Then this sits at the bottom, right? Because this is this square root of this, right? Still sits at the bottom. So 1 over cosine alpha, right? So now cosine alpha simplified down to just 1 cosine, right? But then tangent is equal to sine over cosine, right? There is a square root outside. So I'm going to simplify with this cosine. So I'm going to put everything into square root. Right, so that is actually d alpha over twice of square root of sine alpha cosine alpha. Right, simplify down to this. and that is further equal to double angle formula. Right. Double angle formula. 2 times square root of half of sine twice alpha, right? Because sine 2 alpha is equal to twice of sine alpha cosine alpha, right? 1/2 just cancels out. So this is my integrand for the second integral, gt substituted with alpha, right? Turns out to be this expression. So that means of course, change the boundaries, right? Old boundaries this, new boundaries that, like I said. So my second integral is equal to, I'm going to take out the constant first. Right? What's the constant? Half. Also have square root of 1/2. I think that should be equal to square root of 2 at the bottom. Right, square root of 2 at the bottom. I think that's the constant. Yes. So to 2 alpha. Yes. So again, new boundary 0 to pi/4. d alpha square root of sine 2 alpha. Right? So the only difference is that I have twice of alpha. Here I have just single x. So I just need to make the substitution 2 alpha is equal to theta. Right? So therefore alpha is equal to half of theta and d alpha is equal to half of d theta. Right? This time. So I2 this time is equal to 1 over square root of 2. New boundary. What's the new boundary now? So that means theta is in alpha between 0 and pi/4. Right, so theta equal twice times 2, right? So everything just times 2. I have 0 all the way up to half pi. d theta, d alpha half, so half taken out. Right? Half taken out, and also d theta over square root of sine theta. Now, right now I have theta, but there I have x, but there is just dummy variable, right? I mean, there is essentially no difference. The only difference is that I have some different constants. There's half times 1 over square root of 2. Right? So that tells me that I1 over I2 is now very easy. Right? The integral is just same thing. Right? Integrals just cancel out. I just have half and half cancel out. Right? Just have 1 over the remaining constant, 1 over square root of 2, that is square root of 2.